I am not going to teach you anything new today. Okay? We learned the chain rule yesterday. Today we're going to keep working with the chain rule. Tomorrow we're going to keep working with more derivatives, and then your quiz is on Thursday. Okay? I will remind you that I am absent on Thursday when you're taking your quiz, which shouldn't be a problem because you're just taking the quiz. But just throwing that out there in case, I don't know. I won't be here before school because we're leaving at 7:15. So, just so you know. All right. We're just going to I'm going to do some examples with you, and then I'm going to give you some problems to do independently, essentially. Okay? The only way you're going to get better at taking derivatives is if you practice them and you encounter different types of problems to where when you see problems like them, you'll have an idea of what to do. Okay? Okay.
Is that squared?
This right here?
Yeah.
Yeah, that is a square. So we have 2 tangent cubed of x plus 2 the quantity squared. We have a lot going on. Okay. Talk about it with your neighbors. What is the outermost function? Make a decision at your table. All right, who says x plus 2 is our outer function? Who says squared? Tangent? Cubed? Okay, I didn't see a hand in this area. Okay. The tangent is being cubed, and that's our outermost function. Let's also talk about that 2 in front, because I know I could hear some people like, what do we do about that 2? Okay, do you remember that constant with a k rule I was talking about? I think this is something, Turner, you maybe asked about last week. Okay? Yes, this 2 is being multiplied to our function, but since it's a constant, he gets to just come along for the ride. Okay? It's going to be 2 times whatever the derivative is. Okay, there's no need to do a product rule. Okay, all right. So our outermost function is that cubic function. All right. So we need to take a derivative of blah 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 cubed. Okay. So we would multiply by the 3, change the power to 2, and then keep everything else the same. Okay. Well, now what is inside the cubic function? Tangent. So now that's the derivative that we need to take care of. Well, what is the derivative of tangent?
Secant squared.
Okay, so we're going to write secant squared because that's our derivative while keeping the inside the same. Inside of the tangent that we just took the derivative of is x plus 2 the quantity squared. So now we need to take that inside derivative.
This is going to be in our quiz. Just ask.
I cannot remember if something this complicated or not is on your quiz. However, I feel like this is a problem that after today and tomorrow, we should be able to handle. Oh, let's talk through this again. We had something inside of our cubic function. So we did the power rule, and we kept everything else the same. Inside of the cubic was tangent. So we took tangent's derivative, keeping everything else the same. Inside of tangent was x plus 2 squared. So we took that derivative. We just kept working our way inside.
So, if you wanted to, like, to make it all could you just put, like, parentheses around the tangent x squared and then just put it to the third?
Yes.
So you can, like, see it going.
Yes. Okay, Maddie asked a really good question. Could you do this? Could you put parentheses around tangent to cube and then do it that way? That is perfectly fine. If your brain works better with that where you can really like see outside in, that's perfectly fine.
Yeah.
That makes more sense?
Yeah.
Okay, good. Look at that a little bit longer. We're not even talking about simplifying right now. Yes, we could rewrite that, but
Oh, he was like, that's it? I was like, yeah, we're moving on.
do you have a question, Colby, or are you just ready for more? Outermost function, what is it? Cosine. Inside of cosine, we have a quadratic, right? Okay, so this is when we have to really rely on our basic rules. What is the derivative of a cosine? Negative sign, negative sign. So we're going to take the derivative of cosine, leave the inside alone. Inside of sine was 1 minus 2x to the second. Let's take that derivative. Power rule. Inside of our power rule is 1 minus 2x. What's that derivative? Negative 2. Yes. We go outside, inside, inside. Okay, Turner.
So if the power of the 2 was outside the second parenthesis, how would you do it differently?
So really, in my notes, I had it written like this. And that wouldn't change anything. I just put an extra parentheses there for some of us who are visual people to see that that is inside. This is still inside of cosine. Do you mean that the square was like on the very outside with the cosine? Okay. Let's talk about that. So you're asking if y was the cosine of 1 minus 2x, all of that squared?
Yeah.
That's your question. Okay. So this is Turner asking another question. You can choose to write this down or not. It will not bother me or him either way. All right, Turner. Okay. So our derivative, now we have the squares on the very outside, so it's going to be very similar to that first problem we just talked about. So we would drop the power, leave the cosine inside. Okay. Inside of the power is cosine. That derivative is negative sign. And then inside of cosine was 1 minus 2x. Its derivative is negative 2.
On the first example, why didn't we take the derivative of x plus 2?
What is the derivative of x plus 2? So I didn't write it. Okay, one more all together. When McKenna asked that question of our homework, what was my suggestion to you with radicals? Rewrite them, because you're not going to be able to do anything with a radical. So my suggestion would not only be to rewrite it, but also write it as a negative power. So now when we take our derivative, okay, we have a function being squared. So our first job would be to take care of that square. Okay. Inside of our square is 1 minus x to the negative half. When we take that derivative, well, the derivative of 1 is 0. We would drop the power and decrease the power by 1. Why did that turn to positive? Because we had a negative in front of it to begin with. So that negative times the negative 1/2 power, we multiplied to be positive x to the negative 3/2. Okay. All right. I am going to choose some problems that I would like you to if you need to rewrite this, that's fine, but I need its derivative. Yep, I'm just not going for that. I'm trying to just get like this. So yes, totally fine. Okay? I am totally fine with you working together.
On here?
Well, you would keep the 2x instead of the x. You would have the square.
Yeah, what needs to stay the same as you? Sorry, I'm just
Well, you've already done the cube by the 3 and squared. So now the tangent has the derivative of secant squared. 2x. And then yes. Okay, Yovana, stay up there. Okay, Yovana's gonna talk through her work.
Okay, so like I took this because it's the k, the constant or whatever, so I put it on the outside. And then since the cubed is the outermost function, or function?
Yeah.
Okay, so I put it in front and then I took the derivative or I lowered the power and then kept the inside, and then I took the derivative of tangent, which is secant, and then I kept the inside, and then you do the derivative of the inside.
Okay, my only thing that we need to fix here is that if we're going to keep the inside, then it needs to be inside of the secant squared. Okay, so you had like an extra x in there. Do you see what I mean?
Yeah.
Okay, and then the derivative of 2. That's beautiful. Okay, do you see what I mean about keeping 2x inside?
Yeah.
Okay, first of all, everyone give Yovin a hand. Okay, who said no? Okay, so tangent of 2x was our next function that we needed to take the derivative once we took care of the 3. So the derivative of tangent is secant squared, but since 2x was inside, 2x has to stay inside of the derivative. Okay, yes.
So since the derivative of tangent is secant squared,
Mhm.
we have tangent squared. So why doesn't that change it?
I don't know if I'm understanding your question. Can you ask that again?
Yeah, I understand.
Like, so our tangent is squared. So, but the derivative of tangent
Uh-huh.
is secant squared.
Yes.
But we have tangent squared.
Right.
So
We
why
have
does that not-
tangent squared because we did the power rule. But inside the power rule was tangent. So if you want to think of this as, oh, my eraser's really big. Like we did 3, and then the tangent of 2x is all squared. And then inside of that square is tangent, and that's how we got the secant squared derivative. Does that help? Okay. Anything else about this one?
So when you do it like that way, do you have to, like once you solve for the tangent derivative, do you have to put the squared anywhere?
You can leave it on the outside like this. Like you wouldn't have to write it like this. I know that these two mean the same thing. So I'll
So like once you go to the next step, like do you put the squared anywhere, or do you just
Yeah,
leave
like
it?
why would
Like do you leave
Why
it
wouldn't we have to
again
do the power
squared to it?
well, we already did the power rule once for the cube, and so we look at inside of the cube was just tangent of 2x. So inside of the cube was tangent of 2x. Its derivative is secant squared.
Okay.
All right, we're having very good conversations. Thank you for asking your questions. No, I don't want that. Okay, I would like you to do this problem. I want you to think really hard about that 1 over x. Is 1 over x, when you get to it, something you should utilize the quotient rule for? I would not waste your time with the quotient rule on that one. I would figure out a different way to do 1 over x when you get there. If you get there. I don't know. So, find this derivative.
Alright. We got
It's the product. It's a product. Okay. Okay, go ahead.
squared?
Yes, but would you agree that this is a product? You're trying to do like the chain rule for everything?
derivative.
Product, so we keep it.
So I think you multiply by negative.
So we don't do the change.
Right, in the product, we're gonna have to do the tangent. Okay, if you haven't noticed already, this is a product, x squared times tangent of 1 over x. That's okay, start it. This is what your quiz is gonna be like Thursday, so the more we can practice, the better. Okay?
So I can do the product.
Okay, you're good so
I
far.
only have one step.
It's the tangent of x squared x.
So you did the derivative of the word, right?
You have to start it now from X Y.
It's like our coding.
Oh.
This and this. I get it. So you have to do
Product.
So because you're here, we have to take the there's one function, but today you got
You just keep multiplying by the derivative inside. What's the derivative? All right, Jessie has her work up here on the board. We have the derivative of x squared is 2x times the tangent of x to the negative first plus x squared times secant squared of x to the negative first times negative x to the negative second. What do you think about that?
What's the negative x?
Okay, so when we take the derivative of tangent, we take the derivative of tangent, which is secant squared, but then inside is x to the negative first, so we have to take that derivative. Negative 1 x to the negative second. Okay, so we had to use the chain rule for the derivative of tangent 1 over x. That's where we saw the chain rule in this one.
Are you supposed to make it look prettier?
Well, I mean, you could. It's kind of nice because x squared and x to the negative second would cancel, and then this would make it subtraction. So you could make it look pretty if you wanted to do that. But this is probably what I'm going to look at on Thursday. Okay, to be very honest with you. If I ask you for the derivative and it's two functions multiplied. If I ask you for the derivative and it's two functions multiplied. Chris, tell me what I need to write.
It's f prime of x times g of x plus f of x times g prime of x.
Okay, so like in that last example, we need to see that we have a product and process in our brains. Okay, I have two functions multiplied together. I need to take the derivative of the first times the second plus the first times the derivative of the second. Okay, you know this. You know, derivatives as functions, we gotta put those two together. We have to recognize when we have a product. What about this? Okay, if you have a derivative of a fraction, that's not something that's easily rewritable. That sounds like a word, right? Okay, like when we talked about, like this one, right? We rewrote that one fairly easily. Okay, not a lot of efforts. I know. You know when you like start to say anything like, "Oh, God, I got backtrack." Okay, I teach math. F of x divided by g of x. If it's something that is not a nice one to rewrite, how would we take its derivative? Okay, Maddie, what would we do?
F prime of x times g of x minus f of x times g prime of x divided by g of x squared.
All without looking at your notes. Good job. Good job. You're ready.
I knew you were gonna call me. You're making eye contact. And
Oh, gosh. Sorry. Am I that obvious?
I was prepared then.
Okay. If you recognize that you have a composition, okay, Nick, how do we take the derivative?
Do f prime of g of x times g prime of x.
And then
Right?
there's an actual problem.
Okay, but what we need to practice is processing what we have, right? You know how to do the product rule. You should know your trig derivatives. You can tell me how to do these things. It's a matter of recognizing what you have, rewriting it if needed, and then executing the rule. Okay? So we're going to practice tomorrow more derivatives. You'll get a review. Your quiz Thursday, most of it is, hey, take this derivative. You'll have a tangent line question here, explain this to me question here. But a lot of it is, hey, take the derivative. Okay, we need to recognize what rule to use when. Okay. Any like big picture questions that you have? No. Okay, so your homework tonight, you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 problems. I am not going to post an answer key, okay? I am not. Okay, most of those are odd, so if you go to Calc Chat, you can look at like the first step in Calc Chat, and just don't look at what they reduced to. Does that make sense? Okay, I'm just going to be very honest with you. I think that you can use Calc Chat just fine in this, and yeah, we're going to be fine. Okay.